Welcome to the presentation of Dynamic Control Unique Control System, a brand new, advanced, fully featured process control system for general public. First, something about process control system. What is it? An example of process control system is shown on the figure. Control system is a hardware-software technology setup that performs automatic control of a technological process. Simple control system, sometimes they are called embedded control systems, consist of a real-time controller or control unit that is attached, connected to sensors, valves, dampers, and so on of a technological process that is controlled. On the other side, a real-time control unit may be connected to some kind of simple or more complex human-machine interface. Programming and design is made generally using computer PC, which is not permanently connected to real-time controller. In case of complex industrial process control system, the situation is slightly different. We have more than one real-time controller or real-time control unit, and we have control network that interconnects real-time control units with servers, displays, PCs, notebooks, and so on. And this side of the network has several tasks. It serves for designing, monitoring, optimization, history recording, and human-machine interface. Now, why a new control system? We have so many different control systems. We have corporate industrial control systems, local business industrial control systems, experimental and embedded control systems. We have hobby electronics control systems. These are examples of companies that are producing such control systems. On the other side, we have process control systems requirements, we have advanced control, we have modern information technology, and we have general public. Why we have these four elements, sectors of control systems? For process control requirements, we have applicability, comfort for design and user, reusability, and design efficiency. Advanced control brings optimal and robust control performance and availability of complex process control and monitoring. Using modern information technology brings other advantages: implementation flexibility, cost efficiency, high performance thanks to modern technology, and permanent development. If the system is available to general public, we have wide use of advanced control system technology. Now, these columns displays how much are fulfilled these fields. In case of corporate industrial control systems, we have complete satisfaction of process control requirements, obviously. On the other hand, advanced control is not very supported. The support of advanced control is relatively poor. In case of modern information technology, corporate industrial systems don't care too much about modern technology. They use generally Windows. They are mostly 2 years behind actual trend. They use only PCs, servers, no support for mini PCs or tablets. For general public, they don't care at all. Using of corporate industrial control systems is limited, restricted to partners of this corporate. One has to be partner. It has to have training. It's not easy to buy such a product. If we look at the local business industrial control systems, situation is slightly different. They also support heavily process control requirements. They are destined for process control, so they are good at this field. On the other hand, modern information technology, similarly to corporate industrial systems, the support is weak. Again, only Windows is used, PCs and servers, that's all. Advanced control systems in local business industrial control systems doesn't exist, in fact. They are more available to general public. They are cheaper considering hardware as well as software, and some of the local business control systems are available to public. One can buy it on internet, for example. Experimental and embedded control systems, they don't care about process control requirements. They are destined for special applications. That's why we see that they support fully advanced control and advanced control tools. They care more about modern information technology. For example, design tools are available for Windows, Linux, Macintosh. Considering general public, yes, there is some consideration. One can buy it, but it's expensive. It's quite expensive. Also hardware. We have hobby electronics such as Arduino. These are for hobbyists, students and so on. Process control requirements are not supported at all. If someone wants history recording, visualization, alarms and so on, one has to build it completely or program it. Modern information technology is supported. Windows, Linux, Macintosh, even smaller PCs can be used with these systems. Advanced control support doesn't exist. Again, one has to program everything. On the other hand, general public availability is full. One can buy on internet, it's not expensive, software as well as hardware is not expensive. So why don't we have universal control systems in green? Why cannot we have full support of process control requirements, full support of modern information technology, full support of advanced control, complete availability to general public? Why not? That is why I think we need a new control system. So, if we summarize a little bit, what are the main control system field flaws? Fully featured control systems, such as corporate built control systems, are expensive, not available to general public. Licenses are expensive, software is expensive, training is required, not accessible to public. By general public we mean professional individuals, schools, small companies. What is our aim? Wide use of advanced control system technology. Use these systems not only for large business factories or products, but also for general public. Another flaw: poor or non-support of advanced control. Except of embedded and experimental control systems, there is practically no support for advanced control which is developed at universities or laboratories. There is no link to advanced control design software. So what are we aiming here is optimized and robust control performance. Thanks to advanced control, we can get really optimal behavior of control. Finally, third flaw: unused modern information technologies. open source platforms, Linux, Macintosh operating systems, modern hardware such as tablets, mini PCs, they are not generally supported or very weakly, aiming decrease the cost of the hardware as well as software. In case of open source platforms, you pay nothing for software. Increase performance. These open source platforms are not only cheap, in fact free, but they are extremely powerful. And increase flexibility, because we can use different kind of hardware for implementation. So we have decided to apply these technologies in our new control system. Satisfy process control requirements. So, for example, history recording, visualizations, alarms, schedules, different kind of inputs, outputs, hard real-time system, all these support to be able to have a universal process control system. Use modern open source information technology. Support Windows, latest versions of Windows, Linux, Macintosh. Support mini PCs, tablets. Use database. Use the most commonly used communication, TCP/IP and Ethernet and web for visualization. And support fully advanced control. Scientific computational platforms. The most common used scientific computational platforms for control design, control optimization are MATLAB and Scilab. Scilab is open source and free clone of MATLAB, in fact. So someone who has money buys MATLAB. MATLAB is used in laboratories, universities, in defense, airspace, automotive research and development. Scilab is used by smaller companies that do not have enough money for license of MATLAB. So we use all these technologies. Now, what is the hardware structure of our new control system? We have, as in any process control system, real-time unit. In our case, we call it dynamic control unit. This dynamic control unit has hard real-time system. Sampling time is 1 millisecond. It means that every 1,000 times per second we read data from sensors and write it to output. We have 64-bit floating point. It's extremely precise computing to be able to really support advanced control. That's why we say we have advanced control support. We have also some tools inside this real-time system that support advanced control. We also support industrial network Modbus and different kind of inputs and outputs. So we have this real-time unit. We have network. Network is built out of Ethernet technology, wireless technology, UDP, TCP/IP and Internet. It's the low-cost, high-performance network. Hardware can be really low-cost up to very expensive, from low performance up to high performance. Visualization and design. We use as a hardware any PC, mini PC, notebook, server, industrial PC. For displaying, we can use even cheapest tablets. So this is our hardware structure. Software. Concerning software, we use only open source and free platform independent softwares. Thanks to this, we have actively developing platforms. They are confirmed, powerful and modular. As a database, we use MySQL. MySQL is extremely powerful, widely used database system. It's free, it's open source. Web servers or web services like Facebook or Wikipedia use this MySQL. So there is no doubt that this database is extremely powerful and really confirmed. For visualization, we use Apache Web Server and PHP. By the way, Apache web server is used by about 50% of all web pages. Again, we have powerful and confirmed technology that will display our process. Finally, for programming and designing, we use MATLAB and Scilab, scientific computational platforms, and inside we have a tool developed by our company that allows us to program our control system. On one side we have visualization, on the other side we have programming. In the middle we have database that is storing all data and enabling communication. And we have this small communication service called User Command Center, which is developed in Java. Operating system can be Windows, Macintosh, Linux. For communication we use Ethernet wireless TCP/IP Internet, and here we can see our real-time units. So what are assets of our new control system? Advanced, fully featured process control system technology is brought to general public. All softwares are for free. Hardware is can be low cost, high cost. It depends on performance we require. So really available to anyone. Technology performance can compete with and even overcome corporate built systems. Our actual test shows that we can compare to any industrial process control system at extremely low cost. Full support of most advanced control techniques. This is thanks to using of scientific computational platforms for designing and programming of our system. Scientific computational platforms guarantees that we will have the most advanced design techniques, optimization techniques available. Constant development is guaranteed by use of widely supported open source platforms. MySQL, Apache Web Server, PHP, these are developed by thousands, tens of thousands of developers and programmers around the world. Excellent price thanks to open source and free software and low-cost hardware. We can use mini PCs, tablets, PCs, notebooks, any hardware. So we have really excellent price, and software is all open source and free. New control system application fields. Our system is universal. It can be applied in industry because we support all important industrial requirements. If there is some requirement that we miss, it can be added. Research, because we use scientific computational platforms and support advanced control, we can use it easily in research. In building technology, the same as for industry. Education, because we use again computational platforms, it's very easy to use it in education to explain to students how to build a real control system, how to do simulations, how process control works. Also in hobby, thanks to excellent price.